Hi everyone, my name is Eric, and this is my final project for digital design. I worked on this project independently. Traditional package lockers can be vulnerable to brute force guessing, so this project implements a hexadecimal package locker access controller using the basis board. The system verifies a 16-bit passcode entered by the switches, supporting 65,536 combinations, and it locks after 3 incorrect attempts. The inputs to the system are the 16 switches and 3 buttons. The 16 switches represent a 16-bit hexadecimal passcode entered by the user. The center button starts the code entering process. The right button confirms the entered code. And the top button resets the entire system. The outputs of the system include 5 LEDs and the 7-segment display. LED 0 indicates that the locker has been successfully unlocked. LED 1 indicates that the passcode entered was incorrect. LED 2 indicates that the system is locked, which occurs after 3 failed attempts. LED 3 and 4 display the binary representation of the number of failed attempts. The 7-segment display shows the hexadecimal code entered using the switches, as well as the verification process. Now I will demonstrate what happens when you enter the correct passcode. So first, I press the start button to begin the code entry process. Then I use the switches to enter the passcode. And for this case, the correct password is boba. And I press enter to verify the code. And since it's correct, it says open. And you can see that the indicator that the passcode is correct is on. Next, I will demonstrate what happens when you enter an incorrect passcode. And I begin by pressing start again. And if I have the wrong passcode and I press enter, it will show error. And the indicator for the incorrect passcode will be on. And you can see that the LED tracking failed attempts also increases accordingly. So this says 1 failed attempt right now. Finally, I will demonstrate the system lockout feature. As I enter the wrong passcode 3 times, LED 3 and 4 will track the number of failed attempts using a modulo 3 counter. So that is 1, 2, and 3. When the incorrect code is entered for the 3rd time, the system enters a lock state and the display shows LLLL. And no matter how many times I press this, nothing will happen. And as you can see, this represents 3 failed attempts, and the indicator for the lock state is on. And the only way to return back to the idle state is by resetting the whole system